Here we have a parallelogram ABCD, and the point M is the midpoint of the side CD. Now, when we extend this line BM, it should meet AD at a point E. And when you join AC, it should meet this line at a point L. So this is the figure that we are given. And what is the result that we have to prove? We have to prove that EL is 2 times BL, or in other words, the ratio EL by BL is equal to 2 by 1. So this is the result that we need to prove. Where have we seen the ratio of sides of a triangle? We see that when we deal with similar triangles. So that is how we are going to solve it. We need to prove two results. First, what we have to do is we have to get two triangles. One with EL as its side, another one with BL as its side, and these two we have to prove them to be similar. But that is just our first step. What is our second step? Once we prove that these two triangles are similar, then what will we get? The ratio of their corresponding sides is equal. Now what we have to prove is that they are not just equal, they are equal to 2:1. Or in other words, this will be a bigger triangle, this will be a smaller triangle, and each and every side of this bigger triangle will be 2 times its corresponding side in this smaller triangle. This is what we have to prove. We will start with the first step. Now, can you think of any triangle with EL as its side? You can see that the only triangle that comes up is ELA. So we will take that. But then when it comes to BL, you have two options. Either you can choose this triangle BLA, or you can choose this one. Both of them have BL as their side. Now here is where you have to take a wise decision. Go back to the question. Notice that it says the figure is a parallelogram, which means what? Opposite sides parallel, opposite sides equal. Opposite sides parallel means what? You can get alternate interior angles, you can get corresponding angles. There is a treasure trove there. So what do? We go for BLC. That is the triangle that we have to choose. That will be the wise decision to make. Now, how do we prove that they are similar? As we said, it is these two lines are parallel, which means if I name this as 1 and this as A, 1 and A are equal because they are alternate interior angles. And if I name this as 2 and this as B, again 2 and B are equal because they are vertically opposite angles. So there we have two sets of angles which are equal, which means using the AA criterion for similarity, good news, we have proved our first part. The first part is done. Now once they are similar, what follows? Their corresponding sides. The first side here, the first side here. Be very careful, don't change the order of the vertices. So the third side here, the third side here. All of them are same. All the three ratios given here are same. So we have got our first part of the proof. But the second part is that we have to show that all of this is equal to 2 by 1. How are we going to do that? Our main goal is to prove that this one is equal to 2 by 1. But then we can reach at the result by proving that any of the other two are of the same ratio. Now tell me, which ratio do you think will help you? Will LA by LC help you, or this one help you? Which one do you think you should try getting such a ratio at? Again, go back to the question. What you have is a parallelogram. So then you take the opposite sides. This one will be your savior. This this one is going to help you out. And how is it going to help you out? You already know that BC is equal to AD because it is a parallelogram. Opposite sides are equal. Now, if by any magic you can prove that BC is equal to DE, there we have got our result. Why is that? Add these two, you get 2BC. Add these two, AD, DE, you will get AE there. So AE by BC will be 2 by 1. So that will be the result we are looking for, and that is how we are going to get our second step. So this is the result that we are trying to prove. Again, let us go down the same road. What will we do? We need to get two triangles, one with the side BC, another with the side DE, and we have to prove that both are similar. Which triangles do you think will help? Here the only thing we can think of is DEM. We can't see anything else, right? So our triangle here will be DEM, and here with BC you can see that there are two triangles which are possible. BCL is possible, BCM is possible. Which one do you think is the right decision to make? Remember, here DEM also has M. So choose one with the common vertex. That way you can go for the vertically opposite angles. That will help you there. Go for this common vertex. And this is not just any vertex. There is something special about it. It is the midpoint of CD. So let us go for BCM. And how do we prove that they are similar? We already did, right? So if this is 1, take this as A. Why is 1 and A equal? Because they are vertically opposite angles. And what about this? Here, these two angles, they are alternate interior angles. Why is that? Because it is a parallelogram. Opposite sides of a parallelogram are parallel. So we have got our two angles that we were looking for. So that means what? These two are similar. So here we got two similar triangles, but then before you write their similarity, be careful. Suppose the first triangle you are taking as BCM. Make sure that the angles coincide. The angle B is equal to which angle here? It is equal to angle E. So where B comes here, here E should come. Similarly, C here is equal to which angle? D here. So where C comes here, D should come here. And the M here and M here. So it is not DEM. The correct form of the similar triangle is actually EDM. BCM is actually similar to EDM. Please get the form right. Otherwise your ratio of the sides will go wrong. So this is how these two triangles are similar. Once they are similar, then what happens? The ratio of the corresponding sides are same. So let us write down them, and then they are all equal. But what are they all equal to? Out of these three ratios, can you notice any ratio which is special? You remember we have still not used the information that M is the midpoint. What does it mean? M is the midpoint, which means DM is equal to CM. Do you see any such ratio here? See this one. This is equal to 1, which means each and every one of this ratio, BC by ED, BM by EM, they are all equal to 1, or in other words, they are all equal. So BC is equal to ED. There we have proved two similarities and we have got two results. Now how do we combine them? This is the value that we need to find. But then let us find the value of this one, and they will be equal, right? So what is AE by BC? Split AE, it is AD plus DE. Split it into AD plus DE. But then what is AD? AD is the same as BC. Substitute it with BC. And then what have we proved? We have proved that BC is equal to DE. So there also, instead of DE, put BC. So this is what? 2BC by BC, which means 2 by 1. Or in other words, substituting in 1, what do you get? EL by BL is also equal to 2 by 1. Or in other words, EL is equal to 2 times BL. So this is the result that we were looking for. Till I meet you again, you take care. Assalamu alaikum.